In today's lesson, we're going to learn about adding and subtracting radicals. We can only add or subtract radicals if they are like radicals. What I mean by like radicals is that they're exactly alike. Their index is the same and what's underneath the radical is the same. If the numbers on the radicals, called radicands, are exactly alike, we'll be able to add or subtract the coefficients of the radicals, bringing down the radicals afterwards. So, radicals here are alike. They are square root 7 each time. So we go ahead and add those coefficients. 5 radical 7s plus 3 more radical 7s makes 8 radical 7s total. And that's our final answer there. Next question here we have again 4 radical 15 minus 10 radical 15. Both are radical 15s and there's subtraction in between them. Combine those like terms. 4 minus 10 gives us negative 6 of those radical 15s. Because we had 4 of them, we subtracted 10 of them, so we have negative 6 left. Next example, we have negative 2 cube root 25 plus 5 cube root 25. So again, we go ahead and combine the coefficients. Negative 2 plus 5 gets us 3. And we keep the radicals as cube root of 25. So it's 3 cube root of those 25s here. Last example where the radical is alike, we have 10 cube root 9 plus 2 cube root 9. So that will be a total of 12 cube root 9. That's how many cube root of 9s we have. We just combine the coefficients. In our next examples, we're going to start looking when the radicals are different. So that means they are not the same number underneath the radical. What we have to do then is simplify each radical until we get the same radicand. If they're different, then we just leave them. Then we will do the same steps of simplifying from before. In the first example, we have negative 6 radical 3 plus 5 radical 27. What's going to happen here is we're going to need to break down these radicals if we can. So I look at square root 3 and I'm unable to break it down. But then I look like the square root of 27. I am able to break it down into factors of 9 and 3, and then 3 and 3 underneath 9. I need 2 of a kind since it's a square root no index. I circled 2 of the 3's. 1 3 is left over. And I cancel out 9 and 27 because I simplified them down. I bring down the first radical because I did nothing with the negative 6 radical 3 because the square root of 3, only factors of 3 are 3 and 1, so it's prime. But this second radical, I have 5 that I bring down, but the 3 that I take out gets multiplied with that 5, and I have radical 3 left over underneath. What happens here is I multiply 5 times 3, which will go ahead and get me 15. 15 radical 3's added to negative 6 radical 3's. When they're the same radical here, you can go ahead and combine their coefficients. Negative 6 plus 15 is going to give us 9 radical 3's total because I had negative 6 radical 3's and I'm adding 15 more of those radical 3's, so I have a total of 9 radical 3's. Next example, we want to simplify negative 2 square root 20 minus square root of 5. When it's just a minus in front of the radical, it's really a negative 1 as the coefficient of that radical. Let's break down which ones we can. So I look at negative 2 radical 20, and I know I can break down 20 into factors of 5 and 4. 4 breaks down into 2 and 2. I cancel out everything I simplified, like the 4 and 20. Circle any pairs I have, like the 2 2's, and underline what's left over, stuck inside all alone, which is the 5. Bringing down the negative 2 already there, it gets multiplied with the 2 of a kind of 2's that I could take out here. Left underneath the radical is the 5 left over. I'm not going to be able to do anything with this second radical, which is reading as -1 times square root 5, because the only factors of 5 are 1 and 5. There is nothing left to do to simplify that prime radicand number underneath the radical. Over here, I multiply the two numbers in front of the first square root of 5, which is going to give me -2 times 2, a -4 in front of this radical 5, and then I will combine it with -1 radical 5s. So coefficients get combined together. -4 minus 1 is -5 of those radical 5s. Because again, when the radicals are the same, I'm able to combine their coefficients. -4 radical 5s minus another 1 radical 5 gives me the total of -5 radical 5s. Let's go ahead and try two more examples here. In the next example, we want to simplify 4 times the cube root of 54 plus 9 times the cube root of -16. I can simplify both, but I want to do one at a time. So I'm going to take the first radical I see, which is a cube root of 54, and think of factors of 54. Two numbers that multiply to 54 are 9 and 6. Then two numbers that multiply to 9 are 3 and 3. And two numbers that multiply to 6 are 3 and 2 here. It has an index of 3, this radical, so I need 3 of a kind to be circled. Cross out anything we simplified, like the 9, 6, and 54. We broke those down, can't use them. But I underlined the 2. It is left alone inside underneath my radical. Bring down the number that was already in front of the radical 4 because it gets multiplied with the triple 3's we were able to take out. Left inside underneath the radical is a cube root of 2 here. Next radical, again, we look to simplify, but the first things first here is when you have a negative under the radical, you must take it out as a -1. So now instead of +9, it's -9 because that -1 multiplied to 9 already out there makes -9. From here, I break down 16 into factors. 16 is 4 times 4. 4 is 2 times 2, then 2 times 2. From here, cross out everything you simplified. Circle 3 of a kind because our index is 3, and underline what's left. What's underlined left stays inside underneath the radical. It has no triple to come on out, but the triple that came out was a 2 here that will multiply to -9. So we multiply the numbers in front of the radical before combining these two terms. 4 times 3 makes 12 in front of the first cube root of 2. And then -9 times 2 makes -18 in front of the second cube root 2. Because they're the same radical, we can now combine their coefficients. We have 12 minus 18 becoming a -6. And that's how many of these cube root of 2's we have for our final answer. Again, it reads as 12 cube root of 2's, and I'm subtracting 18 more of those cube root 2's, leaving me with -6 cube root 2 total. Last example, we want to simplify 2 times the cube root of 1080 plus the cube root of 135. We break down one at a time because they are not prime, so they're both able to be broken down. I'm trying to get them down to the same radical to combine them. If I can't get them to the same radical, then I can't combine them. So let's see what happens when I break down 1080 into factors. So that's a large number, but remember, if it ends in 0, it's divisible by 10. So that would be 1080 divided by 10 gives me 108, and those are my two factors. Factors of 10 are 5 and 2. Factors of 108 are 2 and 54. Factors of 54 are 6 and 9. Factors of 6 are 2 and 3. Factors of 9 of 3 and 3. I know when to stop when I have all prime numbers, which means that the only factors left are the number and 1. Cancel out everything we simplified, the 1080, the 10, the 108, 5, 4, 6, and 9. It is 3 as my index, so I need 3 of a kind for it to come out. I have 3 3's and 3 2s, but only 1 5 that I can't break down anymore, so it's left inside. What happens is the 2 that's already from the problem in front of the radical gets multiplied with another 2 I took out from the triple twos being there, and a 3 that I took out from the triple threes being there. Left inside the cube root is our 5 that we underlined with nothing left to match it. 135 is going to be 5 and 27 here. Factors of 135 are 5 and 27. Can't break down the 5, but I can break down the 27 into 3 and 9. 9 breaks down into 3 and 3. I know when I'm done when I have all prime numbers at the end of my roots. Cancel out everything we simplified, which was 135, 27, and 9. We broke those down, can't use them. At the end of my roots, I have 3 of a kind of 3, so I circled them because my index is 3. I need 3 of them. And I underlined the 5 that's left. It is already simplified, but not able to make a triple with anything, so it stays inside. I bring down the addition side it had in the problem, and it's really a plus 1. Again, if there's no number there in front of the radical, it's 1 that I will then multiply with the triple threes I took out. Left inside my cube root is going to be a 5 that I underline here. Now, what I do is I make sure to multiply all numbers in front of my radical before combining these two terms. 4 gets from 2 times 2, and then I multiply 3 here to make 12. That's what I got from 2 times 2 times 3, and that's 12 cube root of 5s. And then over here, I will be adding 3 because I have 1 times 3, which is 3 of those cube root 5s. Cube root 5 is the same number underneath as well as the index, so I'm able to just combine their coefficients. So 12 plus 3 gets me 15 of these cube root 5s. Makes sense because if I have 12 cube root 5s, then I add 3 more cube root 5s, I will get 15 cube root 5 as my final answer.